In this section, we're talking about similar figures. Two things that we're going to do. We're going to determine if two figures are similar by setting up a proportion. And then if two figures are similar, we're going to find the missing side based on similarity. So the first thing we need to talk about is what congruent figures are. And congruent figures are two figures that are both the same size and the same shape. So if you took one figure and put it right on top of the other, they would be exactly the same. That's what congruent means. The symbol for congruent is this. It's an equal sign with a line over it. So in this case, I didn't draw them very well, but you could say the red square is congruent to the blue square. They're the same size and the same shape. Similar figures are two figures that are the same shape, but they don't necessarily have to be the same size. They could be, though. So here, the red and the blue square are congruent because they're the same size and the same shape, but they're also similar because they're the same shape, but they don't have to be the same size. The symbol for similar is just that squiggle on the top. Corresponding parts are two sides of similar figures that are in the same relative position. They match up, basically. They're in the same spot. So if I drew like a triangle here, I drew that red triangle, and then I drew a bigger blue triangle here, you can see that this side matches up with this side, so there are corresponding parts. This side right here matches up with this side, so there are corresponding parts. And that side matches up with that side, so there are corresponding parts. The really important part of similar figures is that their sides are proportional, which means they form a proportion. That's what we're going to use to help us determine first if we have two figures, are they even similar? And then if figures are similar, that's what's going to help us find missing sides. So the first thing we're going to do here is we have two rectangles, and they're the same shape, they're both a rectangle. They're not the same size, so we need to determine if they're similar. To do that, we're going to see if their sides form a proportion. So first we need to figure out which sides are corresponding. So here in this rectangle, 8's the longer side, so we can say that matches up with 10 because that's the longer side. So I can start my proportion by putting 8 over 10. Actually, I shouldn't call it a proportion yet. And then I can say that this side 7 matches up with this side 2. Now here I have to put 7 on top because 7 and 8, they came from the same rectangle, so they kind of have to match up with where I put them. And 10 and 2 come from the same rectangle, so I'm going to put the 2 on the bottom. So now if those two ratios, the green ratio and the red ratio, form a proportion, then I can say that those two rectangles are similar. So to check that, I'm going to cross multiply. So if I do 8 times 2, I get 16. But if I do 7 times 10, I get 70. Since the cross products aren't equal, they don't form a proportion, which means that this bigger rectangle right here is not similar to the smaller, skinnier rectangle. Try to check to see if these two triangles are similar by setting up two ratios and then checking to see if they form a proportion. Pause the video. When you're ready to check your answer, press play. So on this example right here, the first thing that I found was what side corresponds to 12. So 6 and 12 are corresponding, so I just put 12 on top, 6 on the bottom. Then I pulled from the same triangle as 12 to put that number on top. That was 5, which corresponded with 2.5. When I cross multiply, 5 times 6 is 30, 12 times 2.5 is 30. So they did form a proportion because their cross products are equal, so yes, they are similar triangles. Here we're told that triangle JKL is similar, that's the symbol for similar, to triangle MNP. So that means because they're similar, we already know their sides are proportional. And I'm trying to find side JL, which is right here. So if I match it up with its corresponding side, that matches up with the side that's 32 inches. And then on this triangle JKL, I have the side that's 18 inches, and that matches up with the side that's 24 inches. So I already know they form a proportion, so I can set up a proportion over here. So I can put 18 over 24 equals x over 32. Now the x has to go on the top of this ratio because the 18 went on the top of this ratio, and they're from the same triangle. So if you put 18 on top, x would have to go on top. Now to solve this, I'm just going to solve like a normal proportion. I'm going to cross multiply. So I'm going to get 24x equals, and I would do 18 times 32 on a calculator, and I would get 576. And then I would divide both sides by 24. And I get x equals 24. So that's my missing side. I can just box it. So you're going to try these examples right here. Pause the video when you're ready to check your answer. Come back and press play. So on this first example here, we're trying to find side UV that I labeled in green. So I also labeled the side that's 14 centimeters in green because they match up, and then 21 centimeters matches up or corresponds to the side that's 15 centimeters. So I set up my proportion 14 over x equals 21 over 15. Your proportion might look a little bit different, and that's okay. You might have x over 14 equals 15 over 21. You might have had the 21 over 15 first. If you look at what you're cross multiplying on your proportion, as long as you're multiplying 21 and x and 14 and 15, you're going to be fine. So you get 21x equals 210, divide both sides by 21, you get x equals 10 centimeters. On this one down here, I labeled again with color to show which sides correspond, and then I set up my proportion, 40 over 35 equals x over 14. Cross multiply, 40 times 14 was 560, 35 times x was 35x, divide both sides by 35, and you get x equals 16 meters. So on this example right here, I'm trying to find side KL. So what I would need to know is what side on the other trapezoid does it match up with? So in this example, it's actually not too bad because I didn't give all the numbers for this trapezoid. I mean, there's only two options. It has to be 36 or 48, so clearly 30 and 36 match up. But one way you can actually do a problem like this is you can kind of manipulate the other shape. If you twist it, then you can actually see that side KL matches up with side RS. So I could put x over 48 and then 30 over 36. So you're going to pause the video, you're going to finish that problem right there, and then you're also going to come down and do the Cape Hatteras Lighthouse problem. You probably want to draw a diagram to set yourself up there. Pause the video, when you're ready to check your answers, come back and press play. So on the first one up here, you just set up the proportion, cross multiply, you end up with 40 feet. Hopefully you're set on that one. Down here, if you draw the picture, here's my lighthouse, and I don't know the height of it, so I labeled it X, and here's the shadow, which was 83.2. Here's my person, who had a height of 5.8, and they had a shadow of 2.5. So at first, you don't even have a shape, you just have a vertical line and a horizontal line. But if you actually picture the sun's rays hitting them, you end up with two triangles. So you have this big triangle right here, and then you have the smaller triangle right here, and their parts correspond. So I took the height of the person, which is 5.8, and I put it over the height of the lighthouse because they're corresponding parts. Then I took the shadow of the person, which it had to match up, that both things on top belong to the person, and put it over the shadow of the lighthouse, cross multiply, and then divide, and you get that the lighthouse has a height of 193.024 feet.